In section 8.6, we're going to work with combining the different things that we have learned about logarithms in order to solve equations. Okay, so one way to solve exponential equations is to use the property that if two powers with the same base are equal, then their exponents must be equal. But in order for me to do that, I must have the same base. So if you look at this equation, this has a base of 25, this has a base of 125, they're not the same. But I could rewrite them to both be powers of 5 because 25 is 5 squared. So this is 5 squared to the x minus 1 power. And 125 is 5 cubed to the 4x power. When I take a power to a power, I multiply the exponents. So this is 5 to the 2x minus 2 power. And this is 5 to the 12x power. And now I have exponential equations with the same base, so I can simply get rid of the base. That leaves me with 2x minus 2 is equal to 12x. When I subtract 2x from either side, I'll get negative 2 is equal to 10x. And when I divide by 10, I'll get x is equal to negative 2/10, which is negative 1/5. Okay, here we have a base of 8 and a base of 16. I could rewrite these both to be powers of 2. So 8 is 2 to the 3rd power. And 16 is 2 to the 4th power. And then when I take a power to a power, I'm going to multiply those exponents. I'll have 2 to the 15x is equal to 2 to the 12x plus 16 power. Now that my bases are the same, I can get rid of them. So I'll have 15x is equal to 12x plus 16. When I subtract 12x from either side, I'll get 3x is equal to 16. So x would be equal to 16/3. Okay, so if you're working with equations, and this is the key for you, is that if you've got x in an exponent on either side of an equation, the best chance you have of solving this is to rewrite the bases of the powers to be the same number so you can get rid of the bases of the power. Right? If the bases of the power aren't the same, you can introduce a logarithm to either side that will break the variable out of the exponent. So writing them as the same base is really going to be necessary in order to get to solve. Okay, sometimes that doesn't work, and we can take a logarithm of either side. This really pertains to when I have a variable as an exponent, but it's only going to be on one part of my equation. So if I subtract 3, I'll have 10 to the 2x is equal to 8 minus 3, which is 5. So I could take a logarithm of either side of this equation, logarithm base 10, that's a common logarithm. So I'll have log of 10 to the 2x is equal to log of 5. That simplifies the log base 10, gets rid of the base 10, and just becomes 2x is equal to log of 5. So x would be equal to log of 5 divided by 2. Now you could plug this into your calculator and come up with a decimal. I'm completely fine with you leaving your answers in this form. Okay, we're going to go ahead and do the same sort of thing with this problem. The first thing I want to do is subtract 1/3. So I'll have 2/3 times e to the 4x power is equal to 4 minus 1/3, but I need 4 to be in thirds, so that's 4 is 12/3 minus 1/3, which would be 11/3. Then I'm going to get rid of this coefficient, the 2/3. I'm going to multiply both sides of the equation by 3/2. So I'll get e to the 4x is equal to 11/3 times 3/2, the inverse here. The 3's cancel, and that's going to be 11/2. And now I want to take a natural logarithm of either side of this function. So natural log of e to the 4x power is equal to natural log of 11/2. The logarithm base e cancels out the base e of the power and just leaves the exponent for x is equal to natural log of 11/2. So x will be equal to natural log of 11/2 divided by 4. Okay, so now when my variable is in a logarithm, what I need to do is different. I won't be able to take a logarithm of either side to solve this, but I can exponentiate either side. All right, so the first thing I'd want to do is isolate my logarithm by dividing by 4. Logarithm base 3 of x is equal to 28 divided by 4, which is 7. And now I would want to exponentiate either side, and the base of my power needs to match the base of my logarithm. This is a base 3. So I will have 3 to the log base 3 of x power is equal to 3 to the 7th power. The base of the power gets rid of the logarithm, and I just have x is equal to 3 to the 7th power. Okay, again, remember this property that we're using here and also on the previous page were those pieces of information I brought your attention to on the top of page 488 in the last lesson. Okay, so if I want to solve this, I'd start, again, I want to isolate my logarithm. I'm going to add 3, and then I'm going to divide by 10. So I'll have 10 times the natural log of 100x is equal to 120 by adding 3. Now if I divide by 10, natural log of 100x will be equal to 12. And now I want to exponentiate either side. This is a natural logarithm, that's log base e. So I'll have e to the natural log of 100x power is equal to e to the 12th power. This eliminates that, and I just get 100x is equal to e to the 12th. So x is equal to e to the 12th divided by 100. Okay, so we've rewritten logarithms on either side of an equation, and then to have the same base, powers on either side of an equation to have the same base and eliminate the base. Here we added the base of a power to either side that was the same base. We've taken a logarithm of either side of an equation to solve. Okay, and if I can add a logarithm to either side of an equation, I can also remove it. So when I have the logarithm of the same base on either side of my equation, I can simply remove that in the same way that I would a coefficient or anything else. So I get rid of my log base 5. I'm going to subtract 2x. I'll get 15 is equal to 3x minus 2x is just x. Okay, so that becomes very, very simple. Okay, same thing here. We've got logarithm of either side. I can go ahead and remove the logarithm of either side, and I'll just get 5 minus 3x is equal to 4x minus 9. If I add 3x to either side, I get 7x. If I add 9, I get 14. So x will be equal to 2. And what this is telling me up here is that logarithmic functions don't include, the domain, meaning the values of x, don't include all real numbers. For instance, this is a logarithm base 10. Is there any power that I can take 10 to that will result in a negative number? And the answer to that is no. So if I were to plug 2 in here, this would be 5 minus 6. This says log base 10 of negative 1, and that violates the principle of what a logarithm is. So in this case, even though I've solved for this, there is no solution, because when I plug it back into the equation, it doesn't work. No solution. This is an extraneous solution. Okay, so when you're working with logarithms, just as you were working with squaring and square rooting equations in order to solve, you want to start checking to see when you plug your solution back in, does it actually work? And that completes section 8.6.